So let's quickly go through the naming convention. And being ABAPers, you already would have taken a notice that what kind of naming convention is generally followed for this EWM module. And we will quickly revisit that topic. We would not be taking too much of time in this particular presentation, but quickly just to align that what kind of naming convention it is followed for EWM. So the namespace for EWM, be it for data dictionary, be it for the function module, baddies, classes, everything, you will find a prefix with SCWM. So in most of the objects related to SCWM, that is the prefix that you will find. And similar for data dictionary also, if you will go to most of the tables, you will find a prefix like that. So if I, or maybe on the table, if I just do an SCWM /*, you will see most of the tables that we use in EWM will be having this prefix. And you can see a whole list of table that is starting with that prefix. And many of these tables we have discussed. So there is nothing that we need to discuss specifically. For example, if I need to discuss about handling unit, so you can see the handling unit identification, header table, log table, HU reference table. So everything you can see. So it makes us easy to find any of the tables or any of the objects related to SCWM because of the prefix. So you don't have to search the entire list of objects. You just give the prefix and then probably it will already filter out a lot of data. Okay, and when coming to the customer namespace or Z objects, again, you can use either Z, Y, or any customer namespace that your client is using. So if your client is using any specific namespace, you are free to use. And of course, you can create with Z, Y, or if they have purchased a customer namespace. Okay, so here are some of the examples. What I would say, what is the preferred naming convention which SAP has been using. Not everything you will find complying to this 100%, but yes, this is the most preferred naming convention which SAP has been using. And I'll quickly show you in the system. Let me start with the tables first. This we have already seen. So if you will see, the application table is generally SCWM and then meaningful name to the table in some kind of short form. If there are some customizing table, if you're accessing the customizing table, then it will have a prefix after SCWM. Another prefix T would be there. And you will find many tables, like even for RF, we have maintained the logical transactions and all those things. So there also you will find some of the tables with the prefix T. Okay, it should be here then. Oh, sorry. So you can see most of the customizing or the data tables, the master data tables that you have maintained is starting with the name T. And this way you can filter out, or if you want to go for specific list of tables, you can see I am looking for something specific. Okay, not this. Okay, maybe with some other description, but anyways, that is not important. It is important that you know the naming convention, and you can see like for monitor description, various nodes, all those configurations, object class, those configurations are maintained in a naming convention where you would have another prefix T in before the actual name of the object is given. Similarly, for views, you will have a prefix P, and I think this is this list like for the domain, data element, structure, table type, search help, even in a similar kind of naming convention is followed, except that you will not have this SCWM over there. So prefix of DO is generally added wherever you see a domain, DE for data element. And again, this is not 100% that you will find each and every object with this kind of naming convention, but most of the object will comply by this naming convention. Then for structures, a prefix of S would be added, something which is a table type that is created. The prefix of T will be added. Search help, SH, NQ objects you already see, and it will be an E. And even in ABAP, you had to have this E for the NQ log objects that you were creating. And one example of each is provided over here. So maybe if you just open anything, you will see. So for example, if I open this data element, I should be able to show you that both data element and domain. So you can see this is the data element and it is having a prefix DE. It is for transportation unit. And the domain inside this data element which is maintained, and this is having a prefix as TO. So when you are also creating your custom objects, try to keep this naming convention in your mind And of course, you will be creating in your customer namespace. So whatever you are using, Z, Y, or any other customer namespace, you are free to use that. But after that, try to adopt these naming conventions. So for example, if you're creating a domain, try to adopt DO. If you're creating a DE, then you are creating a data element. And this will help you to maintain your objects or maintain your application in a better way, because even other application developers or other person who's trying to access the object, just by looking at the naming convention, they would be able to relate to some extent that, okay, what kind of object it is. Okay, then moving on to the next slide. Again, most of it is self-understood. For example, classes, even in other modules, if you will look at the standard classes, SAP has been following this naming convention. And here for it, of course, there would be a prefix SCWM. So after SCWM, CL would represent, CL underscore would represent it's a class. IF underscore something would represent it's an interface. And then for report programs, they are also adding a prefix as R. Function group, no specific naming convention for function group. Again, it will be only the prefix will be here, but the rest of the things you can create according to your customer need, and then you can give a meaningful name, like what kind of function modules that is going to be saved in that function group. Okay, here this is for BADI implementation. BADI implementation class, you will have a prefix CL underscore. After that, you will also have IM, and this we have seen in many examples. So again, this is for PPF schedule. So we know the BADI name. Let me go to that. Okay, what is the BADI name for executing a PPF action? I'm talking about the BADI name. You tell me the rough text so that I can search using the text that you're giving me. Okay, it is execute something. So maybe I will give like this. No, execute, EXEC, not execute completely. Yeah. So EXEC method called PPF. This is the BADI name for executing your PPF action. And then you have eval something for schedule condition evaluation. So if I do like this, you will see that evaluate schedule condition PPF. That is for schedule condition evaluation. So any one, if I see, so you will have an interface. This is the interface. I need to go to the implementation. I can go from here. Okay. So most of the implementation, you can see that it is CL underscore IM. And again, don't get confused with the different prefix. Maybe these are used in different areas. But if you see everything with SCWM from here, starting from here they are following IM, all this, and all this action we have already seen. HU label we have seen, HU content we have seen, HU hazard express we have seen. So all those was there in the HU label only. So you can see the implementing class is having the naming convention CL underscore IM. And as I said, it is not 100% adherence. So you can see some of the classes, maybe, I don't know what is the purpose of these, but not everywhere they are using CL underscore IM. They are using something else as well. So yeah, here also till here, it is adhering. So yeah, it is not 100% that it will follow the same naming convention, but most of it will be following that naming convention. Okay, so then this is about the objects that you will be creating, what kind of naming convention. And again, similarly, if you are creating your custom objects, if you're creating a custom class, you know what kind of naming convention you should be following. So if we are using the Z namespace, then it will be ZCL underscore something. And if you're creating an implementation, your custom implementation, then probably you should be following ZCL underscore IM underscore then the meaningful description that you are giving. Okay, a few more. This is regarding the enhancement implementation. So we have the BADI definition or implementation if you're creating, maybe for implicit enhancement or explicit enhancement. If you're creating an implementation, then this is the naming convention that SAP will be using. And similarly, when you are creating those implementation, you should be following this kind of naming convention. So EI is enhancement implementation. CX, of course, we know CX is used for exception class. So CL is normal class and CX is the exception class. So CX here also is used for the exception class. Okay, this is something little bit important. We use this in other modules in ABAP as well, but there probably we have we have not done that much programming in object-oriented and BOP framework. If you have worked, then that is, of course, you are already familiar with these kind of naming convention. But since in EWM, we are using classes, we are using object-oriented programming, we are using BOP framework. So there are a lot of objects, there are a lot of parameters which are local, there are a lot of parameters which are global. And then, of course, all the importing, exporting, changing parameters will definitely be there. But along with that, you have the local instances, local parameters, as well as global parameters. So again, you will see that generally a naming convention which is followed for all such kind of objects that are being created. So if you are creating, let's say, variable or a structure or table, then you will be generally seeing a prefix type T, S, C, O that you have already seen in the previous slide. But I am more talking on these rows. So if it is an importing parameter, it's a variable, then it will be IV. It got shifted a little bit. Okay, this is a little bit confusing because this should have been the next column, but that is fine. You just take notice of this columns. So IV is for the variable, IT is for table, IS for its structure. This is for the importing parameters. And if you are importing an object reference, then it will be IO. Similarly, for exporting parameters, everything will be prefixed with E, EV for variable, ET for table, ES for structure, and EO for object reference if you are exporting. If you're changing, if it's a changing parameter, then I will be substituted with C, and then you can see the corresponding naming convention for table, structure, constants, and object reference. Similarly, if you are receiving returning parameter, then you will use R. So I will be again replaced with R, and then the rest of the objects would also be aligning with it. Now, in classes, we have seen that there are some local variables, some global variables. I think in each and every class, there would be some. So let me open any one. Where is that implementation gone? There is nothing. Let me see the exception class. Yeah, they have not used the naming convention, but that is okay. So if it is a local attribute or a variable, generally you will find a naming convention like this. So LV for local variable, LT for table, LS for structure, LC for constant, and LO for object reference. And similarly, if it is a global parameter, L will be replaced with G everywhere, and that will represent the global variables. And that could be used across the class or at other places. Okay, it is mentioned here. So GB is for global. And then you have something called as static and instant. So if you are using a static attribute, then it would be prefixed with S. And if you're using an instance attribute, then it would be prefixed with M. Again, these are the recommendation, and most of the places SAP would be using it. But again, it is not necessary that each and every object that you're seeing, that even SAP is not following these kind of naming convention with 100% compliance. So you will find some examples where this is deviating. Okay, so that is it on this presentation. I will close it. Then I will also open useful baddies. Okay, so according to the process, a list of baddies has been provided. There is nothing that I could be explaining until and unless you implement those baddies. You will not be able to see how and with what data it is getting triggered. But yeah, based on the previous project experiences, some SAP documentation for different components and different processes, these are the baddies which you will be using. So for if you are using Wave for triggering your deliveries, then these are the baddies that you could be using. Then similarly for warehouse task creation, you can see a big list over here. So according to the different actions, like if you're doing something warehouse order creation, then this is a function module. This is again a function module. Anything related to posting change, then these are the baddies. For warehouse task confirmation, these are the baddies that would get triggered. For determination, these are the baddies that would get triggered. A removal strategy, again, these are the baddies that would get triggered. And of course, when you are searching for a baddie, you can refer to this list, but the best way is that you put your own breakpoints. You check what are the baddies that is getting triggered, and then you check the parameters, importing, exporting parameter. The data that you need is in the scope of the baddie or not. All those things that you will check. and then you will implement the correct baddie according to your need. But of course, this list will definitely help you to filter out many of the baddies, so you don't have to check each and every baddie that is being triggered or that is being called in that particular process. Maybe you can already put filters on some of those, and then you don't need to check each and every baddie. So yeah, this is the list that you can refer. Similarly, this is the list for warehouse task, the list for warehouse order. Here also you can see some of the baddie names, and they have given a very nice diagram. So how the process is created and in which step which baddie could be triggered. So that will also help you to filter out most of the baddies, irrelevant ones. Okay, so this also I will close. Any questions before we move to the next topic that we have today? Okay, so now we are going to discuss about MFS. Okay, so we are going to cover these topics mostly to MFS. So let us discuss about this. Okay, very high level. So what is MFS, and what is why we need an integration between EWM and MFS, or the material flow system that we know? Why we need that? So so in this slide we are discussing about what is the business need. For that we need to implement the integration between MFS, or we would require a material flow system, and various critical business needs could be addressed using this. So the most important one is integration with automated system. So if you will see these PLCs, these are programmable logical control. I forgot the full form of it. So what do these PLCs, or let me quickly check the full form as well. Yeah, programmable logic controller. What it is, we will understand that. I have some diagrams open as well, so I will show those diagrams and then you will get a better picture of it. So what happens is, there are, if you have ever seen automated warehouse, when I say an automated warehouse, I mean most of the processes are happening automatically without any manual intervention or without any physical person doing those activities. And then you need an integration point, because all your logistics, all your warehouse related activities will be performed in SAP, and those automation would be performed by these controllers. So these controllers, you can consider these as a robots, maybe a robotic arm, conveyor, or a vehicle which is controlled by programming logic. And you need an integration point. So this MFS, which is available in SAP or in the SAP ecosystem itself, that helps you to connect your SAP EWM system or send out signals to these controllers. So you do not need any additional interface or an integration point. You can integrate SAP EWM and MFS, and this is available in your same environment, I should say. So both these components are available in the same environment, and then you just need to establish the connection by doing certain configuration. Of course, you need to maintain some master data. You need to maintain the link between those things, and then MFS will send signals to all these components. And what all these components could be, I would be showing that in a while. So this is one of the advantages of using MFS, that you can integrate with automated systems, be it devices, conveyors, or anything. Then the second is efficiency in material handling. So just try to compare, if you are manually picking up a pallet from your conveyor belt and then taking that and putting it on high rack storage. Now compared to that, now your warehouse is an automated warehouse. So if specific handling unit is moving on the conveyor and it reaches a specific location, then there would be, let's say there is a robotic arm which picks the pallet from the conveyor, puts that pallet on a vehicle, which could be an automated guided vehicle. And then that vehicle will take it to another location. From there, another location, maybe another robotic arm will pick it and it will put it on the crane. And from the crane, it will automatically put that on the high rack storage. I know you are not able to visualize this, so let us try to see in images that what do I mean by when I'm saying a conveyor, what do I mean by an automated guided vehicle, what do I mean by cranes and high rack storage, what are those things. So these diagrams that you are seeing, consider so this is not automated one, this diagram you could see. So consider these are small tin boxes, but consider these as a pallets. So you can see, let's say this is a moving system. I hope you can see my screen, right, with this image. Yeah. So this is a moving system. The crane, the conveyor that you're seeing, the blue patch here, that is a moving system. It will move, and that will bring the products from coming from the left to the right. And then this is what you're seeing in orange is a kind of a robotic arm that is doing some function over here. Let us assume the function it is doing is it is picking up this tin pallets or tin boxes and putting it on something else. What something else it could be? It's a small tin pallets, but yeah, I mean you can try to visualize what it is going to do. So let's say similarly you had this automated conveyor where you are getting those pallets, those big boxes, and it is having barcodes already attached to it. And here there would be scanners as well. So somewhere here, like I mean here you're seeing there would be scanners which would be continuously scanning all the barcodes that is sticked or that is labeled on your pallets. And then if it is to be picked, then a robotic arm will pick that pallet and it will put it on those vehicles. And the vehicles which I'm talking about, those are automated. There is no person, there is no warehouse worker who is driving those vehicles. So let us see the image of that. So you can see this is your AGV, and you can see the AGV is carrying a pallet, and you can see one here as well. So there are a couple in motion, and there are sensors. When you are designing your warehouse, you are designing the layout, and then like these AGVs are also programmed. They know the path. So let's say they have your robotic arm has picked these boxes and placed it on this AGV. And now AGV knows that, okay, it needs to take this boxes from here to place it on the high rack storage. So you can see here blue bars like something. So let's assume that is the high rack storage. It will take from here, and then automatically it will drive and it will go, and maybe another robotic arm will pick that from there, and it will put it on the high rack storage. So again, on my screen, you can see there are various boxes. So if you, for example, if you look at this image, you can see the robotic arm is kind of picking up those boxes and putting it on the racks. So this is still a small rack. So this robot is directly placing. You could have cranes as well. So this is what I was trying to explain. So let's assume this is the robotic arm which is picking these boxes and putting on your storage bin. If you talk about the high rack storage automated one, so it will look something like this. You can see it will be probably 3-4 floor height. The height of this could be 2 floors, 3 floors, depending upon how you have designed your warehouse. I think this is the good image. Yeah. And then this section that you are seeing over here is a moving section. So you can see it will move on this pillar. And then once your box is placed on this, then there is already signal. So through the configuration, already signal has been passed that, okay, what is the storage bin where it should be placing this particular box. Then it will move up. It will move sideways as well. And then it will place your box in the correct bin. Maybe there could be different kind of strategies you're using, first in, first out, last in, last out, whatever you're using. Accordingly, this movement will happen and it will put your boxes in the correct storage bin. So whatever steps I have mentioned, from the conveyor, there is a robotic arm that is picking up your boxes. It is putting those boxes or pallets on the automated guided vehicles. Then automated guided vehicles travel on its own through the programming that has been already fed. There is a direction, the layout which has been provided. Everything has been provided to that. It will drive automatically to the destination location. There, probably it will place it on a crane, and then the automated crane will again move upwards or maybe sideways, and then it will put that pallet or it will put that box or material, whatever it is, in the correct storage bin. All these things has happened without any manual intervention. Yes, in case of failure, let's say your AGV stopped for some reasons or something happened in between. Let's say there is an accident, because when we saw AGV moving, you will see that there is a very clear path. Is nothing that is placed in the path of AGVs. So let's say by mistake something or someone is moving in this AGV path and then this AGV stop. Then you would require a manual intervention. You would remove the blockage and then the AGV would move, or maybe like in the case of conveyor, if it was not able to scan your HU. So here, when this robotic arm is picking up your pallet, it needs to scan that, okay, it needs to scan and know that, okay, this box, I need to put it on this AGV. And if it is not able to scan, then even on the conveyor, there are two directions. So if it is not in the correct zone, if it has not been read, then probably a non-OK zone or an exception zone could be defined. And that particular pallet will be moved there. And then probably the warehouse executives would come, they would fix the label, and then they would again scan it, and then the rest of the processing would happen. So in an ideal scenario, when everything is working fine, you do not need any manual intervention. Everything will be taken care by the robots. But in case of exceptions, in case of failures, yes, you have provisions to restart the channel or maybe redo it or manually do it. Any questions so far on this concept, how it works on the images that you have seen? Have you ever seen any warehouse or any of these automated things in anywhere, maybe in a shop or anywhere? Have you seen this? That will help you to relate this pretty well. So I have worked for warehouses where they are achieving 99% automation. So you will hardly see any worker on the warehouse floor. They are there, but just for supervision activity. So they are not on the floor. If the warehouse is designed, they have a monitoring zone, which will be like, from one floor higher, they would be monitoring all these activities. And in case of some failure, then they will actually go and fix that. Otherwise, it is 99% automation. So for such scenarios, MFS comes into picture. That is the integration point between your EWM and all these automated conveyors, automated PLCs, what we are discussing about.
What sets ZaranTech apart in SAP corporate training? It's our unique blend of expertise and innovation. We offer customized courses tailored to each client's needs, ensuring relevant, targeted learning. Our vast trainer database brings you wisdom from the best in the field. Need resources? Access our extensive training material repository anytime. We are all about measurable results, providing detailed student metrics to track progress. And we don't just teach, we build community. Join our thriving social media network, connecting learners beyond boundaries. With ZaranTech, you are not just training, you are transforming your SAP expertise.
Okay, so you can see in this diagram, if your MFS was not there, then probably you would have required third-party MFS, which would have been the integration point between your EWM and those PLCs. So what are the advantages this MFS is bringing? It is helping us to integrate our EWM with those PLCs. It is very efficient. Because you can see the material handling, if it is done automatically, probably it would be efficient. It would, in long term, of course, it would be cost friendly as well. Initial setup could be high, but in the long term, because of the efficiency of large warehouses where you need a lot of processing, this is very useful. And of course, real-time data processing and tracking. So using the MFS also, you can track that, okay, which PLC, what is the current status of the data, what is the current location of the data. So all those things can be tracked, and then everything could be planned. So if a shipment arrives, what action needs to be done and where it should be placed, all those things will be defined and will be taken care here by the MFS. Okay. So again, similar diagram. So this you can consider as an high rack storage. And I talked about the crane, and you can see the different position of the crane. So let's say the crane was here. Now probably it moved up, and here you can see another position. So if you have, let's say, a rack placed here, then from it will move up to this place, and then it will move the material into this rack. Similarly, if you have a rack or storage bin over here, the crane will move up and then it will move the material in that particular storage bin. We talked about the AGV or the transfer car. So you will see that there is a designated path which it has been assigned, and the programming has been done for that. So it will move in this path to and fro. It will pick the material from one end and then it will transfer it to another end, or maybe whatever the destination is. So maybe if it is needs to move from here to this third one, then yes, that also could be done. So everything will be controlled automatically. You don't need to tell that, okay, from point 1 to point 3 or point 1 to point 2. When you are determining your storage location, warehouse process type, everything, the signals would be sent to all these PLCs. Okay, another way to represent this. So you can see here, there is a scanner which is placed, and then it will scan the barcodes that is available over there. And then based on the barcode, it will take action. So whether it needs to be put on this car, or whether it needs to move further in the conveyor, whatever action that needs to be done, it will be performed. Okay, some of the responsibilities, what PLCs would be doing. So real-time monitoring of sensors, real-time control of drives. Yeah, this is fine. I mean, we have already discussed about these. So we will see where this is configured. We'll try to see that as well, how this is configured. To some extent, we'll see it requires a lot of configuration. Not everything we will be able to do, but to some extent, I'll show you how these are done and what are the responsibilities, what are the things, or what are the integration points. Those things I will show you. Okay, so how are they integrated? So how your MFS and then your PLCs are integrated. Okay, so if you will see the MFS part controls the movement and controls the sending the signal to the PLCs. And your EWM system is interacting with your MFS. So through your warehouse task, you are telling your MFS that, okay, this is the warehouse task. Let's say if it is a put away warehouse task, then according from what location, what storage bin to what storage bin, or what intermediate bin this put away should be done, then that kind of signal you will send to the MFS. Then MFS will identify the PLC that, okay, when I say PLC, consider everything as a PLC. So the conveyor is a PLC, your AGV is a PLC, your crane is a PLC. So everything which would be acting upon your signal is a PLC. Then MFS sends those information to those corresponding PLCs. And then PLC would, based on the signal and then based on the programming on which it is working on, it will take the necessary action. So you can see the warehouse task. It is sending information to MFS, and then MFS will be communicating with PLC. So the PLCs are already defined. What type of PLC, what is the PLC name to which it is going to send the signal. And to send a signal, till now, you know that to communicate, you are using IDOCs, you are using proxies, you are using APIs. There are different communication techniques you have been using. Here in MFS, it is Telegram. So we will see with the Telegram that it is kind of an, I should say, a structure. It is of course a structure, but if you try to write the data in a flat file, you know the position of that structure. What do I mean by that is, let me try to explain that. Okay, so let's say I have a structure, and in that I have, let's say, key, which is of type 5 character, name, which is of 10 characters, last name, which is again of 10 characters, mobile number, which is of, let's assume, 12 characters, and then email is of 15 characters. Now I need to send all this data. So how will be my key? Let's say 1, 2, 3, 4, 5. Name, although 10 characters are available, but I am utilizing 2, 2, 4, 6. Okay. Mobile number, again, I am utilizing only 9 characters. Okay. Now, if this information I need to send in form of text, how will this be done? I will do 1, 2, 3, 4, 5 immediately, or no. But now if you see the number of characters that is need that is available for the name is 10. But in my name, I am utilizing only 6 characters. What about the remaining 4? Should I start my second name immediately from here, or I would leave 4 spaces? 1, 2, 3, 4. Have you ever worked on DL11 files where you are storing information like this in flat file? How those information are stored? Is it stored like this, what you are seeing on this current screen, or is it stored like this? How it will be stored?
So we have to give those spaces.
We have to give those spaces, correct. So if there are 10 characters for this name, then it will automatically reserve those 10 characters. And if it is occupying only 6 characters, the rest 4 characters will be blank. So similarly, after now 5 characters will be blank. 1, 2, 3, 4, 5. Then mobile number, then 3 characters will be blank. And then, yeah. So this is how your data would be sent. So of course, in MFS, you have structures defined like this. So you will populate the data, but when you are sending it to the PLCs, it is sent like this in form of a flat file. So again, the telegram is something like this. The data will be converted in the telegram and it will be sent to the PLCs. And then based on the structure that is already agreed, they would be able to parse this data and they will be able to read that, okay, this is my mobile number, this is my ID, or this is my Gmail ID. So whatever information they need, they will pass and they will read that information. Okay, so coming back to this slide. So EWM, we already know that it is taking care of your material information, your warehouse activities. And if it is any kind of an flow that is required, material flow that is required, it will send that information to MFS, and your MFS will communicate with your PLCs. It will communicate with your automated devices. And these PLCs, generally, they are third-party providers, maybe like Cummins, or there could be different organizations who are developing or who are programming these PLCs. So again, when you are designing your layout, you need to have very clear communication that your integration, these are the structures, these are the data points that we are going to use, and everything is discussed and finalized. So that activities will of course be done. Now, in some cases, you will be receiving communication back from these PLCs as well. So for example, let's say you have sent a signal that, okay, I am just checking whether my connection with the PLC is working fine or not. So in that case, it will give you an acknowledgement back that, okay, this is working fine. So some kind of an OK signal or an OK signal, whatever you have defined, it will give you that signal. And then even when you are sending that, let's say the move telegram, so that you are moving this pallet from one location to another location, you should get a response that, okay, this move telegram has been processed, or it is in the queue, whichever states that you have defined, and you need to receive those notifications. So that is also possible. So again, that will also happen from telegrams only. So they would be sending you the notification or the confirmation back in form of telegrams, and then you will receive in MFS, and then from MFS, it will be processed or communicated back to the EWM. And accordingly, let's say if you have given a move telegram, so of moving pallet from your conveyor to your high rack storage. So you need to change the status as well, right? So you need to change that, okay, the storage bin has been updated, or maybe if there is a status change which is required, you need to do the EWM. So based on the confirmation that you receive, you will change those flags or you will change those status in the EWM system as well. There are channels, there are queues. Why this channel? So let's say your PLCs will not be moving one pallet always. They could be like picking up 2 or 3 pallets. So then those will be sitting in your queue. And then according to the queue, it will be processed in the first come, first serve, or in the first in, first out manner. So whatever that is in the queue in your channel first, and that will be processed, and then the further processing will be done. Okay, this is one diagram to represent the same thing. You can see the queues are determined, and then there are different queues. And what you are seeing, this conveyor system 1, conveyor system 2, these are nothing but your PLC. So let's say this is one PLC, this is second PLC, and then based on the queue, so this queue is for this PLC, even 2 and 3 is for this PLC, and then you are defining this Q3 for this PLC. So queues are PLC relevant by customizing and PLCs and other subsystems as well. I'll try to show this in the system. I don't think there is any data for MFS is maintained, but I'll try to create, and the basic ones I'll try to show. Yeah. So between your SAP system and the PLCs, either it would be through RFCs or TCP IP. So that kind of communication. Again, I mean, this is not always necessary. This is not a hard rule that it will be through RFCs only. Between, again, based on what type of PLCs, who is your implementing partner for the PLCs, you could have a different communication channel that could be defined over here. And then, of course, but the communication from MFS to PLCs will always be happening in form of a telegram. So that's the reason it would be very well supported in RFCs and TCP IP, because there you would be sending data in form of a flat file and it would be sent directly. Okay, this we have seen what kind of equipments may be integrated. We have discussed about that. So it could be conveyors. All these things would be there. I mean, scanners at conveyors, pallet conveyors, fine. I mean, all types of conveyors will be there. You will have automated guided vehicles, that also we have seen. You will have cranes, you will have transfer cars. So these are just the names that you will see, you will hear when you are working for an EWM project. You will hear about these terminologies a lot. Maybe they are saying transfer cars, they are saying AGVs, they are talking about conveyors. Then you should understand that, okay, what they are talking about. Okay, so basic components of MFS we will be discussing. We will be going into the system and we will try to see the basic concepts. What is a communication channel? What is a communication point? PLC's type? All those things we will be seeing in the system. Okay, so we are going to this node SPRO, and again in SPRO we will go to HCM, Extended Warehouse Management, and in Extended Warehouse Management again we'll go to the node which is just below that, and here you will see another node which is for material flow system, which is MFS. I will expand this node and we need to do a lot of configuration. So not everything would be possible to do and show, but I will try to show you the basic concepts that I have just spoken about. So most of the things is in the storage data and then storage control and telegram processing. So at least the things I'll show you, it might not be fully done, but yes, let's see here. Okay. So you see the first node in the material flow system master data, that is defined PLC type. So what is PLC type? And we have discussed programmable logical control. So let's say you are having 10 AGVs and then you want to group those 10 AGVs as one PLC type. Then you have, let's say, 5 conveyors. You want to group those 5 conveyors as one PLC type. So in PLC type, you are defining a type which will be grouping multiple PLCs into one group, and then all similar processing could be done based on the PLC type. So first we need to define a PLC type. Let's see. Okay, so this is the warehouse number 1710. And then I'll give any type. Let's say I am giving A for AGVs. So AGVs. Similarly, if you want to give more, you give one more. So it is C I'm giving for conveyors. Okay, so then you define the interface type. You give any name, which we are going to use when we are defining the PLCs. We are going to use the PLC type as well. So then now we go to this next node, which is define programmable logic controller. And we go to this node. Okay, there is an entry, one entry, maybe I'll create a new one. This is also fine. So you can see this is the warehouse number, and then you give a PLC name. So this is any name that you can give. So I have given, let's say for conveyor, I have given convert 1, or maybe whatever name that you are using according to the naming conventions that you will give. Then you will give the descriptions. And here in the interface type, you will give the PLC type. So if I do an F4 help, you will see that the interface type that we had defined in the previous node, that is coming up over here. So I am creating it a conveyor 1. I will use C. And then you define rest of the data. So warehouse process type, what process type it should trigger in case of a failure. If there is an exception code that you have defined. So there you can see there are already some exception code, standard exception code that you have defined. let's say I do it as a stock removal denial, whatever. I'm giving some exception type that will be defined. You are also given the PLC mode, what kind of PLC it is, that description, the mode you're defining over here.
What sets ZaranTech apart in SAP Corporate Training? It's our unique blend of expertise and innovation. We offer customized courses tailored to each client's needs, ensuring relevant, targeted learning. Our vast trainer database brings you wisdom from the best in the field. Need resources? Access our extensive training material repository anytime. We are all about measurable results, providing detailed student metrics to track progress. And we don't just teach, we build community. Join our thriving social media network, connecting learners beyond boundaries. With ZaranTech, you are not just training, you are transforming your SAP expertise.
And then I will save this as well. Okay, so the PLC type and PLC we have defined. Now you need to define the communication channel. So this communication channel, this will be defining how your, let's say, MFS will be communicating with the PLCs you will be that you have defined. I have defined only one PLC. Let me try to create one more. I'll create a new entry, or in fact, okay, 1710. Now I will give it as AGV1 and then make it vehicle1. Now I will choose the interface type, AGVs. I will give this only. I mean, I'm not worried about what the value I'm giving. Then exception code, fine. Okay, now in the communication channel, I need to define that this node, okay, this PLC will be communicating with this MFS using this communication channel. So that I will be defining over here. Okay, and here you will, maybe I need to create a new entry. So I will give the warehouse number 1710. You take the PLC for which you want to define this communication channel. Let's say I want to define for AGV. Then you give the communication channel. Let's say I give it as an interface I. Yeah, I is fine. Then you are giving the rest of the settings. So in the rest of the settings, what you are giving. So let's say when sending your communication from your MFS to this particular PLC, what you have defined or what you have mapped here, AGV1, if that telegram or if that communication fails, then how many retries you want? Let's say I want 5 retries. So it will try 5 times automatically. If it does not succeed in 5th time, then it will error out. But at least 5 times it will retry. Then you are defining the interval, that in what is the interval that this should be retrying. I think this is in seconds. Let's say I am giving it as a 10 seconds. So maybe in every 10 seconds, it will try to process that. Then you have a handshake mode. So that is important. We talked about the confirmation, we talked about the notification that you are sending a telegram to this particular PLC, then how you will be getting the response. So in response, you want the complete telegram to be sent along with, if there is some column for populating your confirmation, you want to send the recipient telegram type and sequence number. Yeah. So you want only these information that this is the telegram type. Let's say it was a warehouse task confirmation. Then you want that, okay, warehouse task confirmation, and this was the telegram type, this was the sequence number, and this was the recipient who has received it. That only you want that to be sent back as a notification. You do not want any kind of confirmation, or you want only the telegram header. So if something you have defined in the header, whatever you want, that will be sent back to you as a confirmation that, okay, this is successful, or maybe in error, it will be sending you the error message. So let's say I want maybe send me only the header, so that I will choose. Okay, so live telegram interval and live telegram type. So this is your checking the connection status. So if you are just checking if you're just doing a connection test, then that is called as a live telegram. So in live telegram, you're checking the connection status between your MFS and the PLC that you're trying to communicate with. So this is, if you have any live telegram defined, what is the interval? It will try to check that. And what is the live telegram type if you have defined any. So no values. So nothing is defined over here. So I'll leave it blank. I'll put this check telegram. Then here also you have the exception code. So in case of error, what it should do, so that you will define in the exception code. Here also no values are selected because you need to define the exception code. There is a different node. Okay, so I will save this. I'll save this. I have created this communication channel I. And let's see, I'll save this. Now, this communication channel needs to be assigned as well. So you have created this communication channel. You go to this assign communication channel to object. So it will be assigned to individual objects, like example, the conveyors or the AGVs that you will be sending this message to. It will be assigning this to that. So 1710 PLCs AGV1 object type telegram type. Or so again you need to give the channel object and communication channel. So I think the IP address is maintained over here. I do not have any information on that, so I will leave it blank at the moment, or maybe just for setting purpose. No, it will not. It will check from some entry. Okay. Then again, you can assign the order in which the communication would be sent, but that's not a mandatory one. You need to define the communication points. So communication point types and communication points. So communication points are, let's say, the sensors or the PLCs or the interaction point. So how your MFS will be interacting with those sensors that you will be defining in the communication point. So here in the communication point, again, you will give a name, you will give the communication type, description. So let's say there is no value for this. Okay, we have not defined the communication type, so that would be fine. And then you can define what it is. You're communicating with a scanner, you are communicating with a clarification bin, ID point, what you are communicating with. So let's say I'm communicating with a scanner, or let's say clarification bin. And then if you want to provide this relevant information, what is the WPT you are going to use, what you need to do in case of error, then those things also you need to define over here as well. So do not worry. I mean, because these configurations would not be done by the technical team. This is the functional configuration that needs to be done, and they will set up. I'll come to the technical part, but I want to just show you a glimpse. What are the components that will be configured. So even if you just remember the name of those components, that will be good enough. So like, for example, what all components we have discussed? We have discussed about PLCs. So that is what that would be defined, PLC type and specific PLCs. Then we have discussed about the communication channel. So this is the channel which will allow your EWM MFS to communicate with individual PLCs. And then you have a communication point. So again, the channel you have defined, and then specific point that you are going to integrate with, that you are going to define over here. Now, again, similarly, you have the exceptions one. Where is that? Yeah, exception handling. So we have been seeing the define exceptions for PLCs in case of error, define exceptions for PLCs access control error, define exceptions for communication error. So you will be defining those exception types over here. And then wherever you have defined the communication point, you have defined the PLCs, and some points we have mapped the errors, or somewhere we do not have any option to map the error. So once you have defined these exceptions, you can map these exceptions to those data as well. Queues, we talked about queues when we were seeing the diagram. We saw that there was a queue as well. Yeah, we talked about queues, that you will have different queues and that will be mapped to different PLCs. So like all this queue 1, 2, 3 is mapped to this PLC, and this queue is mapped to this PLC. So you will be creating those queues, MFS queues, and then resource type, and that will be mapped. So if you go here, okay, there are already a lot of queues defined, so you can use that and you can map it to that. Okay, this queue will be assigned to this PLC. So for example, we have created 2 PLCs, maybe some more configuration is required to have it over here. We have defined 2 PLCs, but that queues could be assigned to the corresponding PLCs that you want to use it for. So that will be assigned over here. Okay, all these things again is not very much relevant for us. What is important for us is the telegram processing. So again, the functional will be maintaining this, but if you need some custom structure, custom telegram type, Then you will create that structure, and then you will provide that structure. You will share that structure with your functional team so that they can maintain the MFS action. So like for a warehouse task confirmation, warehouse task creation, whatever MFS action that is being triggered, what is the telegram structure that you are going to use for that? So if I go to this node, so let's say ZNT, it is 2 characters. Okay, I need to provide a function module. I have the baddie names. I don't think I have a standard function module. No. For the action, you need to provide a function module. So in here, you will be creating your Z function module, and which you will be assigning over here. I will, for time being, I'll assign any standard function module. I'll not be executing it, so that should be fine. Okay, then coming to this telegram structure. So you are defining the telegram structure for PLCs and for PLC interface type. There are already standard telegram structure available. You can use those, or if you want to create, then it is an SE11 structure that you need to create and you need to assign over here. So if I go to define telegram structure for PLCs, create a new entry. I need to give the warehouse. Let's check for AGV. I have not defined the telegram type. So let's say WNTO and then telegram type. So what type of telegram? Is it for a synchronous message send? It is a live telegram, what it is. So let's say if I give it as warehouse task creation, warehouse task WNTO, and then I need to give a structure name. I'll go to SE11. Okay, so you can see there are a lot of telegram structures, mapping structure for warehouse task confirmation, mapping structure for HU in telegram. So I think this I can use because this is for warehouse task confirmation. So I will have, and let me check for warehouse task creation also if it is there. No. So let me check this one. Okay, it is just a confirmation. So this telegram is not relevant for us, but this is how you know that, okay, what activities you are performing and what all data you need to send. So maybe for when I'm creating a warehouse, I need to send a lot of information maybe to them. And then I need to look for a corresponding structure. So let's say if I am sending a confirmation, then this structure would be suitable. If there are custom fields that you need to send, then maybe you could use an append structure, or it is better to create your own structure and then you can map it to the corresponding telegram type. But it is better to have your Z structure rather than appending in the standard one. So that way you're not modifying the standard things. So let me, for time being, just maintain this. Then this is done. Define telegram structure for PLC interface type. So we had already, I think we did create an interface. Let me see. Yeah. So this is not it. There are still there are so many nodes, and I have created some random data. Not everything is linked, but again, all this data needs to be configured before you can actually trigger a telegram and then you receive a response or a handshake from. You need to have the IP address. You need to configure the destination. All such things needs to be done. But what I wanted to show you is the main important terminologies over here, like PLCs, the communication channel, communication point, exception code, FSQs, the telegram type, the structure. So all those things we have seen in the slide as well, and where these things will be mapped in this configuration data. Now you will be able to relate. So once you check your production system or your development system, if all these configurations are done, then you will be able to relate that, okay, what it is talking about. Then master data is done. Then this also. Okay, then storage control also will be done. So this also configuration needs to be done. So LOSC and WPT, all those configurations needs to be defined. The link has to be defined, and then it will work. So this is on the configuration, the master data side. How do we monitor? How do we see the telegram? Then if you go to, and let me see here as well. No, this is fine. I think some settings needs to be maintained here as well. Okay, let's see. And then I go to warehouse monitor transaction. Then you see a node in the standard warehouse monitor. There is already a node, material flow system. So if you will see all those things that we have defined, the telegram, the confirmation, everything you will see over here. So I don't think there is any data at the moment. Nothing is there. Yeah, nothing is there. But you can see if you want to filter it based on the warehouse task number, application log, time, handling unit, warehouse order, all such things you can do. So if I click on this, PLCs, communication channel, communication point, telegram type, handling unit, if you know the handling unit number, then you can filter your telegram based on those data as well. Then again, you have other nodes also to filter, like based on the communication channel, communication point, handling unit, resource, everything. You can see all those things. Then again, I'll try to get a screenshot from one of my projects, and then I'll just show you the screenshot that how you see those information over here. Maybe on the configuration side also, I'll try to get some screenshot which I could share. I'll do that. Then coming to some other structures, we have seen the structures that will be needed for, like, the telegram type, so that you will create and that you will share, so that it could be used by the functional. And now there are some important function modules or baddies, rather, I would say. And then let me go to that baddies section. So you can, of course, do the same way search, but I will. Okay, there are many. Right. So, but if you will see the descriptions, of course, these are the baddies that you will be using. So if it is anything related to manipulation of telegram acknowledgement, so something you want to process when you're getting your confirmation, then you are going to make use of this baddie. Something while determining the communication channel, if you want to process something, you want to do any kind of manual intervention, anything, then you are going to implement this baddie. Check inbound telegram for error. So I think this will be called when your inbound channel is going for error, then probably that baddie will be triggered. But I want to show you few more. So yeah. So while sending the warehouse task information, if you want to edit something, then this is the baddie that you're going to use. So filtering and changing of warehouse task before sending telegram. So this is something you will be using a lot, because when you're sending your warehouse task, then you are going to make use of this baddie, and you have an implementation, a standard implementation class, which you can refer while creating your implementation. So only some of the logics needs to be updated, not everything you will update. So copy most of the things and then add your custom logic according to your business need. Similarly, this was for warehouse task. There is one for warehouse order as well. Yeah. So warehouse order determination, warehouse order determination 2. And if you will see, this is redetermination of next warehouse order. So again, if you are processing your warehouse task and while determining the warehouse order, if you want to do certain processing, then you are going to implement this baddie. Then third one, there is one with send as well. Okay, it is SMD, not SEND. Okay, so this is for manipulation of your send telegram. So if while sending the telegram, anything that you are sending, if you want to manipulate your telegram structure, then you are going to implement particular baddie. Okay, in fact, I should be making these notes in your here as well. Okay, similarly, this is for send. You have something for receive as well. So while you are getting the acknowledgement, you are getting the notification. If you want to do some kind of processing, or if you want to manipulate something, then this is the receive telegram, the receive baddie definition, and that you are going to make use of. Okay, what other two we had discussed and receive? Yeah, warehouse determination. So this is also, and then there was one for warehouse task as well. Okay, then there are some core baddies, which is for general posting and updating. It is not only would be MFS related, but could be used somewhere else. But even for MFS, it would get triggered. So because here everything will be warehouse task related, your warehouse task confirmation, cancel, you will be creating a task for moving the pallets. So these are the important ones related to warehouse task, everything that has been listed. Okay. So we have also discussed how you will see, and the best way, if you don't remember, of course, you will find it in the debugger, but most of the baddie related to MFS, you will get it with this name. So you will get most of the baddie like telegram acknowledgement. We have seen warehouse task determination, warehouse order determination, telegram send, telegram receive, everything you will get, telegram acknowledgement. So all those you will get, whatever I have listed down. But these are the ones which are important, which we are going to use, in fact, when we are implementing anything related to telegrams or MFS. That is the reason I have included this here.